Hey guys, Mr. Gran here, FST 8.2, multiplying and dividing rational expressions. These are some of the more difficult versions of 8.2 for the simplifying part. So if you feel like you're up to it, you remember some of this factoring from when we did polynomials, go ahead and pause the video and give it a shot. Otherwise, resume the video whenever you're ready. Okay, so looking at this one. First thing that we should always think about is a GCF. Now the tricky part here, this is not in standard form. So right away, let's rewrite that in standard form just because it's a little easier to look at. And then both the numerator and the denominator in standard form, so that makes things line up a little bit nicer. Okay, the top has a GCF. 2 and 10 are both divisible by 2. However, this is a negative 2. If your leading coefficient is negative 2 in a math class, chances are you need to factor out a negative number. So instead of taking out a 2, I'm going to take out a negative 2. Now what's left on the inside? The negative 2x, when I take out a negative 2, is just x. When I take a negative 2 out of the 10, it makes it a minus 5. Now if I lost you there, sometimes this is easier to understand if you distribute it back in to see what happens. If I take that negative 2 and I distribute it back in, negative 2x and negative 2 distributed to the minus 5 makes it a plus 10, so we're back to the original. Remember, when you're factoring, you're not changing the value of something, you're just reorganizing it in a convenient way for solving a particular problem. Okay, the denominator does not factor at all, so now I've got x minus 5s that cancel out. And my answer for this one is just negative 2, but we still have a domain restriction. X cannot equal a positive 5. Maybe put a comma in there because that might look a little bit confusing, like negative 2x doesn't equal 5. Okay, this is a similar one. We've got a GCF and a negative leading coefficient. So instead of taking out an x, I'm going to take out a negative x. And then I've got x minus 3. Again, if I distribute the negative 3 or the negative x back in, this would be a negative x squared. This would make it a plus 3x. All right, the denominator. Now we've got a slide and divide type problem. So we'll take that 2 and move it over here. I'm going to kind of factor it down this way before I write it in my the next part of my work. So that's x squared minus 7x plus 6. What does that factor to? Multiplies to positive 6, adds to a negative 7. That's going to be minus 6 and minus 1. And then we got to divide, right? So the 2, we divide the 6 and the 1 by 2. 6 over 2 reduces to an x minus 3. And then this one doesn't reduce, so that becomes 2x minus 1. So the x minus 3's cancel, and so what I'm left with, negative x over 2x minus 1. What can't x equal? The x minus 3, that one's easy enough. We just change the sign. It's positive 3. This one, maybe you remember a little shortcut that you took when we were doing polynomials. Otherwise, we can always set the factor equal to 0, right? Then if I add 1 to both sides, I get 2x equals 1. And I divide both sides by 2, I get 1/2. So my domain restrictions are at positive 3 and positive 1/2. All right, our next two. I'm going to need a little bit more room to work here. A lot of sliding and dividing on this one. So this one I'm going to go like that. I'm going to kind of have to work upwards for that one. X squared plus 7x plus 12. Multiplies to 12, adds to 7. That is plus 3 and plus 4. Then I got to get a division in there. Dividing both of them by 6. This is one where both of the numbers, both of the fractions reduce, right? Partially reduce. 3 over 6 reduces to 1/2, and 4 over 6 reduces to 2 over 3. So now both of these are going to get the denominator to move out in front. And this is going to start to reduce to 2x plus 1. And this one is 3x plus 2. All right. Now the denominator, let's work on that. So I'll bring the 6 over. And I've got x squared minus 5x minus 36. Multiplies to negative 36, adds to negative 5. That's going to be a minus 9 and a plus 4. And then if I divide both of these by 6, again, it's going to be ones where both of them partially reduce, right? 9 over 6 reduces to 3 over 2. And 4 over 6 reduces to 2/3. So now I can take those denominators and move them in front, and I've got 2x minus 3 and 3x plus 2. The 3x plus 2's cancel out, so my simplified version, 2x plus 1 over 2x minus 3, and what can't x equal? I might need to set up both of these. So 2x minus 3 equals 0, and 3x plus 2 equals 0. And just a little bit of two-sided algebra now. We get x equals 3 over 2, or x can't equal 3 over 2. And negative 2 over 3. Hopefully that doesn't look so terrible on the screen. All right, let's get rid of all of this. All right, this one, the top, the numerator does not factor, but it gives me a pretty good hint as to what one of the factors is going to be down here. For this to work out, it really needs to have one factor cancel. Otherwise, it's not a very good math problem. Okay, so bring the 3 across, x squared plus x minus 12. Multiplies to negative 12, adds to a positive 1. That's going to be plus 4 and minus 3. And then we'll divide both of them by 3. This one doesn't have any partial reductions. 4 over 3 doesn't reduce. So that's your 3x plus 4 that's going to cancel out the top. And then 3 over 3 reduces to 1. So the 3x plus 4's cancel out, and what I'm left with, if everything cancels out of the top, right, everything cancels out of the numerator, that doesn't mean that that numerator is 0. It means the numerator is 1. So 1 over x minus 1. And then what can't x equal? Can't equal a 1 for the x minus 1. And then if we do 3x plus 4 equals 0, and a little bit of algebra, we get 1 and negative 4/3 are our domain restrictions.